We're now going to turn our attention to the Java Supplier functional interface and show how to combine it in the context of the Java optional class. And this is a very interesting type of functional interface. It gets used a lot to create things. That's why it's a supplier. It's often used as a source of some values, and it gets used quite a bit in factory methods, as we'll see later. And we'll apply this in the context of a concise example that showcases the Java collection frameworks, hash map class, and the optional class, which is a very interesting class. If you're not familiar with it, hopefully it'll teach you something worthwhile to learn about how to get rid of the plague of null pointer exceptions. So what is the supplier functional interface? Well, it returns a value and takes no parameters. So it's kind of lobotomized in a way compared to what we looked at before, where we pass parameters to predicate, we passed one parameter to function, we passed two parameters to by function. Now we're going to be taking a look at something that takes no parameters, at least no notional parameters, and then we go ahead and return a value. As before, this is a generic interface that's parameterized by a single reference type, which is the return type from the get method, which is the single abstract method that has passed no direct parameters and returns a value of type t. We'll see, however, you can easily pass parameters when you use get by using various types of effectively final values. So how can we apply the supplier functional interface? Well, this particular example is kind of a whimsical one, which you can find in my EX12 project in the FP folder and the modern Java GitHub repository. And what we're going to do is we're going to use the supplier functional interface in conjunction with the Java optional class to print out a default value if a key is not found in a map. So let's take a look and see how to do this. So the first thing we do is we're going to make ourselves a map, which I call being map, because I'm going to have the disposition of different beings. So a demon might be naughty, an angel might be nice, a wizard might be wise, et cetera, et cetera, et cetera. So that's going to be the map we're going to make. And then we're going to go ahead and get a name from somewhere, the name of a being. We're going to prompt the user. We're going to read it from a file. We're going to get it from a GUI, whatever. And then what we're going to do, because we don't know whether or not that name that was provided by the user actually corresponds to a key that's in the being map. So to avoid having to deal with null pointers, what we're going to do is we're going to say beingMap.get, and we're going to pass in the being name that was given to us by the user. Now that could come back with the corresponding disposition like naughty or nice, but it also might come back with a null if there's no mapping. So what we're going to do is we're going to wrap that call with the optional of nullable factory method. And an optional is essentially an object that either has a value if it's present, or if it's no value, it's called absent. And all the operations essentially become no ops if the optional doesn't have a value. So we're going to store this disposition into an optional string, which, as I said, is a container object that may or may not contain a non-null value. But the good thing about using optional is you never have to worry about null pointer exceptions because you never work on null entities. What we're then going to do is we're going to print out the disposition of the being. And we're going to say disposition.orElseGet. And the way that orElseGet works is if there is indeed a value, like it was a demon or an angel, then it returns the disposition, naughty or nice. However, if there was no value, then it's going to go ahead and take the result that's passed in here, which is a supplier lambda. So it's going to say, please pass in the string unknown. Now, this particular example is a little bit more complicated than it needs to be, because using a supplier allows you to make these decisions dynamically at runtime. If you don't want to make these decisions dynamically, then you can use other means. So orElseGet uses a lazy supplier lambda parameter where it can actually make decisions dynamically at runtime. Here's an alternative way of doing things where you use the orElse method on optional, which just takes a string directly. So this is going to take the string that's passed in here, as opposed to using a supplier, which gives you one extra level of indirection to make a dynamic choice. So the way to look at this is orElse uses an eager value parameter, whereas orElseGet uses a lazy supplier lambda parameter. There's one other way of doing things, and I would be remiss if I didn't explain this too. If you don't want to go to the trouble of using optionals, there's a method that's defined on map called getOrDefault. And as you can see here, what you do is you pass in the parameter, the key that you're trying to look up. And if it finds it, great, it gives you back the disposition. But if it's not there, then you can pass in a parameter that you want it to use, which in this case would be the string unknown. So just another way of doing things, just showing you a different variant. But of course, the purpose of this discussion was to show you how suppliers work. So let's go ahead and talk now about how the optional class uses the supplier functional interface. And you can see we're going to look at the orElseGet method. And as you can see here, orElseGet takes a supplier parameter, and this is a generic type. And what's going to happen here is if the value is not null, then it returns the value. Otherwise, if it is null, we're going to say other.get. And that will go ahead and do this dynamic call, which is lazy, which will get back the result that we expect. So in this particular example that we used, we bound that supplier to be the string unknown. The string literal unknown is bound to the supplier lambda parameter. But we could have done other things. We could have a supplier object that would dynamically generate values there. And so what will happen, of course, is when the other.get method is called, it'll just return the string unknown. So we never end up getting nulls. We always end up doing something. It's just in some cases we get this supplier parameter. In other cases, we get the actual value that was stored earlier in the optional. So that's the end of our lesson that demonstrates the use of the Java supplier functional interface in the context of the Java optional class.